All right, so what we're working with today is the last of our types of transformations. We've had rotations, reflections, and translations, and the last type is a dilation. And what happens with the dilation, it's similar to what happens when you go to the eye doctor. They dilate your eyes. And so a dilation is either an enlargement when it gets bigger, or a reduction when something gets smaller. So what we do is we're either going to blow things up or they're going to get smaller. The factor that we blow things up is the scale factor. This is K. So for bigger things, K is going to be greater than 1. For smaller things, K is going to be less than 1. It can't be a negative, so it's always going to be greater than 0, but it's going to be some kind of fraction between 0 and 1. So let's say I have a rectangle and I make it smaller. I'm trying to make it half the size. So this would be K is equal to 1/2 because I made it half the size of the original one. Let's say for this one I have a quadrilateral, but I want to make it 3 times the size. So if I try and make it 3 times the size, K is equal to 3. Okay, so that's what happens. Things are either going to get smaller or they're going to get larger, and you find out how much by looking at the K, the scale factor. So let's look at these first two, determine if it's an enlargement or reduction. And so this is my original paper clip because it says, or safety pin, because it's P. And so now this is my new one, so this got bigger, so this is an enlargement. The way you find K, K is the new distance over the original distance. So my new distance is from C to C prime because this is new. So my new distance is 12 over my original distance, which was 8 to my original safety pin. So that means this reduces to 6 over 4, which reduces to 3 over 2. And so that's my scale factor. When I look at this red paperclip on the right, my original paperclip, because it doesn't have, it's the pre-image, and this is my image because it has the prime, my image shrunk. So this is a reduction. And again, it's the new distance, so the new distance is 18 over the original distance to my original paperclip, which is 30. So that reduces to 9 over 15. And so that reduces again to 3 over 5. So to find the dilation, the scale factor, you have to remember it's the new distance over the original. Now let's just do a couple examples. Now what's nice about these is that I have, where's my cursor? So I have my A is 2, negative 3. B is negative 4, 6. And C is 12, 15. Well, the first thing it tells me to do is it just tells me to multiply. It says that my scale factor is 2. So that means all of these numbers get multiplied by 2. So A prime is 4, negative 6. B prime is negative 8, 12. And C prime is 24, 30. And that's all I do. I just multiply everything by my scale factor. Here, my scale factor, this is a reduction because it's a fraction and it's less than 1. So I'm going to multiply everything by 1, which doesn't change it. So really, I'm going to divide everything by 3. So I have my points. And I'm going to divide each of those by 3. Now I can't divide 2 by 3, so I just write 2 over 3. But negative 3 divided by 3, I can do that. That's 1. And then, oops, that should be B, not A again. So I can't do negative 4 divided by 3, so I just write it. But 6 divided by 3 is 2. That'll work. And then C prime, 12 divided by 3 is 4. And 15 divided by 3 is 5. Now, there's one other thing that you could see. You could see it in notation. So I want to do a problem with notation. Just where'd it go? Let's insert some space and get it to work. Okay, so what you could see is you could see a problem. Shut up, dogs. You could see a problem. You could see a problem that says xy goes to 4x and 4y. This is just an enlargement, and you would multiply everything by 4 because the scale factor is 4. So sometimes you're going to see it written like this, but you just have to realize it's telling you to multiply those by 4.